Kia ora koutou. I'm going to start videoing some of today's level 3 calculus questions. I'm going to start with one of the excellence questions from complex numbers. And I really like this question. It's a locus question where you have to think about a tangent to the locus. And I'm going to draw a graph in here. Now, you didn't have to draw a graph to get this question fully right, but for me, it really helped me see what was going on. So let's just start off by reading it. We've got a straight line with this equation. So notice that this straight line is going through 0, -1. M is a real constant, M is positive, and it's a tangent to the locus described by this. Now, I'm going to do this question first, assuming that you haven't done that much with loci problems, and so we're going to do it algebraically first. Then at the end of the video, I'm going to show you how you could speed yourself up quite a bit in here. Remember, I haven't seen the mark schedule, so I don't know exactly how much working they're going to want. So as usual, we're going to start by saying let z equal x plus iy, and we're looking for a set of points, set of z values, x plus iy values, that satisfy this thing here. And then the last thing we've got to do is figure out something to do with this tangent. So substituting in, I get x plus iy minus 2 plus I is equal to √3. So you can do this blindly without really knowing where you're going, but I'll show you the geometry of it near the end. Grouping into real and imaginary bits as usual gives me this. And then applying the definition of the modulus gets me this, x minus 2 squared plus y plus 1 all squared, square rooted is equal to √3. Now squaring both sides really easily gives me the equation of the locus. And you can see that what we've got is we've got a circle, the centre is at 2 minus I, or 2 -1, and the radius is √3. And now what we have to do is figure out what is the value of m where this straight line is tangent to this curve. So let's have a look on the graph. Well, we know that we've got a circle centered at 2 minus I, so I have very roughly put this in here. This is rougher than I would usually do in a video, but there you go. The radius is √3, so we know that this is 2. √3 is 1.7 something, so we're going back to around here. And now we're just going to draw a very bad circle. And we know that the tangent has equation y equals mx minus 1. So if it's a tangent, if we draw that in, we don't have to find the point where they meet, right? We just have to find what the slope of that line is. So y is equal to mx minus 1. Because it's a tangent, it's only going to touch once. And so that's what we're going to try and solve. That should make you think straight away of a discriminant where the discriminant's equal to 0, right? Because the other options, and I'll just try and change pen color, are that we have a line that is going through here, but that instead of being tangent, it's not tangent. So if it's not tangent, there are a couple of things that can happen. The first thing that could happen is it could cut through twice, and that would mean that the discriminant was strictly positive. And the other thing that could happen, you can probably see where this is going. Where are we? Where's my ruler? Is that if it was like this, there would be no solutions to this solved simultaneously with the locus equation. So what we want is the value of m that's going to give us just one solution. So if we go through here, one solution for y equals mx minus 1 and this. So we're going to substitute this in. Nice things are going to happen in here. We'll have x minus 2 all squared plus mx minus 1 plus 1 squared is equal to 3. X squared minus 4x plus 4, and the minus 1 plus 1 here goes away. So we have plus m squared x squared is equal to 3. So x squared into 1 plus m squared minus 4x plus 1 equals 0. One solution means b squared minus 4ac is equal to 0. A is equal to 1 plus m squared, b is equal to -4, and c is equal to 1. So b squared minus 4ac is equal to 16 minus 4 times 1 plus m squared. That has to equal 0. That gives me 12 minus 4m squared equals 0, giving me two solutions. 4m squared is equal to 12, m squared is equal to 3. Now, usually here we'd go m is equal to positive 3 or negative root 3, but we know that m is strictly positive, so m has to equal the square root of 3. And if you look on the graph, you can see, even just from our slightly dodgy sketch, that that looks perfect. So just a couple of things about how you could do that faster, and this just goes to whether you have to do that algebraic step here. So I've done, like, I haven't done that much algebra, but I have done this, and then I've done this line, this line, this line to get to here. But if you've done enough work with loci, you can actually hop straight to seeing that it's a circle like this. So I'll just show you how to think about that, especially for people who maybe are in year 12 and might want to redo this next year, although right now you probably can't think of anything worse. So here we've got z minus 2 plus I is equal to the square root of 3. So if you regroup that slightly and write it as z minus 2 minus I is equal to root 3, and remember that this means the distance from this, the distance from 2, negative 1, and the point has to always be this. Then what that's describing is a centre here of 2, negative 1. So the distance from here to our point has to be root 3, and so that's your definition of a circle. You can go straight to the locus equation from that. But sometimes I think NZQA has been a little bit funny about how they mark it if you don't show the algebra. If you've done Cambridge A-level, you'll be very, very confident with doing it without the algebra, but hopefully you put a wee bit of algebra in today. Okay, that's enough from me on that question. I really like it. I think that was just a little bit different from the usual locus problems. I'm going to do question 3E later on, which I really didn't like. I found it quite mechanical and boring and involved, but I will try and work through that one in an hour or two later on tonight. Thanks for watching.